I want you to imagine, as best you can, Italy in the 1930s, minus the World War II era fascism. Vittorio Spamer, an assistant professor at the historic University of Pavia, was studying rabbit intestines. Rabbit guts may be less than appealing to the average person, but Dr. Spamer had just made an interesting discovery. There was a compound in their lining that hadn't been identified or classified before. As humble as this discovery began, it would lead to the key ingredient of some of the most commonly used medications in psychiatry today. So, what did Dr. Spamer find? What was a future psych medication doing hanging out in rabbit guts? Let's dive in, shall we? So, how'd Dr. Spamer land on rabbit guts anyway? Well, he specialized in studying drugs from natural sources, like herbs or animal products. And for his most recent research, he was interested in compounds that caused smooth muscle contractions. So think like the muscles used in your blood vessels or in your throat when you swallow food. While studying rabbit intestines, Dr. Spramer noticed that some of the cells in their lining, enterochromaffin cells, secreted a product into the mucus layer that lined the rabbit's stomach, likely to help with digestion. He isolated this unknown product and named it enteramine. Enter for the enteric nervous system in the intestines, which is where it was found, and amine for the type of chemical compound it was. In the years following, Dr. Spramer would go on to find enteramine in other sources as well. He found them in mollusk hearts. By the way, mollusks are animals like slugs, mussels, snails, octopuses, octopi, clams, oysters, scallops, you get the point. He also found them in the salivary glands of an octopus. Today's fun fact, an octopus has salivary glands. Over a decade later, in the late 1940s, a team of researchers, Dr. Irvin Page, Maurice Report, and Arda Green, would unintentionally add to this body of work by investigating a completely different topic, hypertension, otherwise known as high blood pressure, at the Cleveland Clinic. Dr. Page wanted to learn more about vasoconstricting substances. That is, substances that would cause your blood vessels to narrow, which in turn tends to increase blood pressure in those vessels. To find and isolate those factors, he first had to encourage blood to clot, similar to how someone's blood would react if they were injured, changing its form from a runny liquid to a firmer gel, a process known as coagulation. There was just one issue. Every time the blood coagulated, a pesky serum formed as a side product, and this serum would have to be removed before Dr. Page could get around to finding the vasoconstriction substances that he was looking for. To help him remove the serum, he hired organic chemist Maurice Report and biochemist Arda Green. It was Dr. Report who decided to try isolating and testing the chemical in this serum for its own vasoconstriction effects. But isolating the chemical itself wouldn't be simple or straightforward. Dr. Report collected around 7,000 liters of blood from a slaughterhouse over a span of 60 trips. He let each batch of blood sit and coagulate for 2 days in a bin lined with cheesecloth, and when enough serum had finally strained through the cheesecloth, it still required a 5-step chemical process to be purified and isolated. Eventually, though, Report tested its effects on rabbit ear arteries that were prepared by Doctors Green and Page. I know, again with the rabbits. The mystery chemical did indeed have a role in vasoconstriction, and after celebrating with a dinner party, Dr. Report and others decided to name it serotonin. Sero, as in serum, and tonin, as in tone, since narrowing blood vessels increases their tone. Dr. Report also proposed a structure for serotonin, which was confirmed in 1951 once researchers began testing how to create synthetic serotonin. But this structure looked eerily familiar to something the scientific community had already seen before, enteramine. The two compounds were one and the same. By the early 1950s, serotonin had been found to have roles in both your gut for digestion and in blood vessels for blood pressure. But what was arguably the biggest breakthrough in how we see serotonin today was yet to come. At that time, the study of neurotransmitters was still in its earliest stages, and a Harvard PhD candidate named Betty Twarog was studying which neurotransmitters affected catch mussels in mollusks. Catch mussels allow mollusks to latch or anchor onto things like rock structures during large waves, and help these mollusks remain tensely wrapped around them while in a low energy state, which is generally helpful for things like catching food. Remember anyone else doing work on mollusks? Yep, Tarog had found Dr. Esperamer's earlier work on finding enteramine, now known as serotonin, and it's then that she realized something big. While norepinephrine was the neurotransmitter responsible for keeping the catch muscles tense, serotonin was what allowed the mollusks to exit the catch state, or in simple terms, let go. As a neurotransmitter, serotonin wasn't just in the heart or intestines, it was in the brain. You would think that discovering a whole new neurotransmitter would be a big deal for science. But, as it turns out, Tarog's paper actually sat collecting dust at the review desk of the Journal of Cellular and Comparative Physiology for a couple of years, because she wasn't a known scientific author at the time. In 1952, a now Dr. Tarog would move to the Cleveland Clinic and join Dr. Page, where she followed up her research with an even bigger finding, one that even Dr. Page hadn't believed at first. The neurotransmitter serotonin wasn't just limited to the brains of mollusks. They're found in the brains of mammals, too. The last piece of serotonin's discovery story comes from a relatively unexpected event: the creation of LSD. LSD, full name lysergic acid diethylamide, is a white, odorless synthetic substance. It's also part of a group of drugs whose name you may have heard of before: psychedelics. Those are drugs that affect mood, thought, and perception of space and time. So, what did serotonin have to do with LSD? Well, Dr. Dilworth Wayne Woolley was a biochemist based out of the Rockefeller Center Institute for Medical Research in New York City. After learning about the structural similarities between LSD and serotonin, he had an interesting hypothesis. What if the brain was just confusing LSD molecules that just looked like serotonin in some ways, but couldn't do serotonin's actual job? And what if it was because of that interference that LSD had its psychedelic effect on people? That would mean that serotonin levels in the body actually play a role in whether people experience psychedelic effects. And if you extrapolate that out, they could also play a role in other situations where people experience abnormal mental states, like mental illness. And that brings us to today. We now understand that serotonin is both a neurotransmitter and a hormone. While neurotransmitters use your brain and nervous system to deliver instructions across your body, hormones use your bloodstream instead. Hence why serotonin was found in places like the intestines and the blood vessels. In fact, what Dr. Esperamer found wasn't a stroke of dumb luck. The vast majority of serotonin in our bodies is actually usually in the cells that line our intestines, with smaller amounts in other organs like our brain. And receptors for serotonin have been found in everything from single-celled organisms to plants to other animals as well. When it comes to bodily functions, serotonin does a little of everything. Feeling down or sad or just mentally off? Well, it helps with cognition and focus and mood regulation. Just ate a meal? It also helps control appetite and bowel function. And if you ate something bad, it also speeds up the process and contributes to nausea, so you can get it out of you. Got injured? It instructs the arterioles in your body, those are the tiniest of blood vessels, to narrow and restrict blood flow so that you don't bleed out. Issues with sleep? It works with other biochemicals like dopamine and melatonin, yes, that melatonin, to regulate your sleep cycle. In fact, you need serotonin to produce melatonin. Low levels of serotonin can cause mental health issues like depression and anxiety disorders, insomnia, digestion problems, and they may even explain seasonal affective disorder, also known by the fitting acronym SAD, which happens when people feel slightly more down and sluggish in months with less sunlight. But too much serotonin, although rare, isn't great either. This causes serotonin syndrome, which can be accompanied by symptoms ranging from shivering, to twitching, to sweating and high blood pressure, all the way up to seizures and abnormal heartbeat. And without timely treatment, it can be fatal. Given how important serotonin is, we've also learned that there are multiple different ways to get more of it. First, our bodies can make it out of the tryptophan we eat. That's why some people claim Thanksgiving turkeys make you sleepy, which is probably a myth, but that's a story for another day. Next, our bodies also store tryptophan, which can be released into the brain and converted into serotonin through activities like exercise. Third, our brain can produce serotonin in response to sunlight. More specifically, sunlight can stimulate our retina in the eye, which triggers the brain to create serotonin. Finally, researchers have since invented a fourth way, one that you've probably heard of: medication. Certain classes of drugs, such as SSRIs and SNRIs, are commonly used as antidepressants or anti-anxiety medications. They work by increasing the level of serotonin, and in the case of SNRIs, other neurotransmitters too, like norepinephrine and dopamine, by blocking its reabsorption into neurons. This keeps these neurotransmitters bouncing around in our nervous system for a longer time than they otherwise would, and thus prolongs their effects on our body. From its relatively humble and accidental beginning, the discovery of serotonin and the things we've learned about it have really revolutionized fields like psychiatry and neuropharmacology, in addition to changing millions of people's lives for the better. That's all for now. If you're interested in more deep dives like this, or in some of the topics covered in this video, like and subscribe for future content. Thanks so much for watching.